I don't know if you've heard of quantum entanglement before, but boy, does it seem to be a very strange phenomenon. And it very much reminds me of what I have observed regarding packets of cards. In particular, if I organize the cards as alternating red-black, as I have here, put them into the box and leave them that way for long periods of time, when I pull them out to work with them, they just seem to have this irresistible force that makes it very difficult to separate the reds from the blacks, as if they have opposite polarity or something. But I doubt anyone would believe me unless they saw it with their own eyes. So that's what I'm doing here today. I'm going to just do what I would normally do with the cards, and together we'll see what happens. I'm going to go ahead and just gather these cards. Okay. Now I'm going to divide them into 8 smaller packets, maybe about the same size, maybe not, doesn't matter. Okay, and then we're going to rosette shuffle them in pairs. So there's one. Okay, and bring those together. Maybe I'll slide those so we have some room to make a mess here. Okay, and then those together. And then we'll just stack them as one big messy packet here. 52 cards. Okay. Now, really, to be able to test my claim about these cards just wanting to be in pairs of opposite color, I thought we better perform this experiment more than once. Not just once, because that really is not sufficient scientific evidence. So we'll do it a few times in different ways and see if we get a similar or the same outcome. Okay, so what I'm going to do is I'm going to deal out the cards into 4 piles. Just 3 cards each will be fine. I'll set the remaining cards here because we'll need them for our future experiments here. I'm going to pick these up, drop those on top, right on left or left on right. If you were here, I'd have you make those decisions actually. Okay, so what I'm going to do is I'm going to mix them here. This is just the Charlier shuffle. Okay. And the interesting thing is, if I deal them out into 6 piles, if I can fit 6 on the screen, let me move these over. If I deal them out into 6 piles, I find that more often than not, the cards will pair up as a red and a black. Oh, we got 1. Oh, we got 2. Up, 3rd one. 4th one, I thought so. 5th one. Okay, well that's the beginning of our experiment here. I think that's some evidence that might bolster our theory here. So let's go ahead and try that again, but we'll do it in a different way. We'll mix the cards in a different way and see if we get a similar outcome there. Okay, maybe we'll drop those over here, left on right. That would be just fine. This time I think we'll just count out 6 cards, 3, 4, 5, 6. Drop the rest on top. And now what we're going to do is we're going to deal them out into 2 piles with random stacking. And so if you were here, I'd have you make that decision. I could actually flip a coin or roll a die to do that. But I'll go ahead and just kind of try to guess what you might say. It really is a free choice. And to really know if these cards have a tendency to come together in opposite colors, it's really best for us to randomize these different elements of our experiment. So maybe I'll stack from left to right. We can deal out into 4 piles. How would you like these stacked? Left to right or right to left? Okay. Oh, sorry about that. Right to left. Very good. Okay. Now at this point, we'll kind of check for pairs in a very different way. I'm going to just Klondike pairs. Oh, there's one pair, opposite color. They found each other. They found their opposite mate there. They did as well. They did. And the king and the 2 did as well. Okay, that is a second kind of confirmation of something weird's going on here. Okay, so let's try that again. Put the rest of the cards there. This time I think we'll go ahead and just kind of flip those. Left on right. That's very good. We'll do a Charlier shuffle as before. Okay. And then we can even do, this is called a serpentine deal. It's kind of a fun one. So this is where you go in the opposite order for the second layer. We can stack from left to right, right to left, left to right. Okay, your choice. Very good. Okay. We can even do an even or odd up jog. I'm just jogging forward the even position cards. Random stack. How would you like those stacked? Right on left? Okay, very good. And maybe we'll even do the serpentine deal one more time. It's such an interesting one where you go in opposite order. Okay, what happened to our pairs this time? Oh, we got one red and one black. You got a couple of twos. That's nice. Oh, wow. Wow. Boy, that quantum entanglement is alive and well here. It's even drawing some card values together. Those must have been next to each other in that deck that I left in the box for all those many months. That is a third confirmation of this weird phenomenon here. Well, we can only do one more because we're going to run out of cards here. So we'll deal out into 4 piles again. 3 cards each. Maybe this time we'll kind of switch these like that. You want left on right? Okay, very good. That would be just fine. Okay, what I'm going to do now is I'm going to do something called a supercut. So I just need you to give me a number between 1 and 7 or something like that. 3? Okay, 1, 2, 3. And then I just move into a Charlier. Another number, 1, 2, 3. Again, okay, that's fine. 7, 1, 2, 3, 4, 5, 6, 7. That's kind of a big number. 5, 1, 2, 3, 4, 5. Move into a Charlier. 4, 1, 2, 3, 4. Maybe just one more. 6, 1, 2, 3, 4, 5, 6. Okay, boy, that's quite a bit of mixing there. And then what I thought we would do is a Pharaoh shuffle. Have you seen a Pharaoh shuffle before? It's kind of a fun one. See, we have 12 cards, so I need to break it exactly in half, and then you just perfectly interlace the cards like every other card, okay? And technically, doing it one way is a Pharaoh in, the other one's a Pharaoh out. Either one works fine is what I have found. And then this time, we're going to test for our pairs by just pushing off pairs. So I'm just going to push off the top 2 cards. Well, we can see that we're having some success. Those we don't know, those we don't know. That looks pretty good. And those we don't know. Okay, so we do have red, black, red, black, red, black. And what about these? Do we have a perfect score in all of this? Oh, that's nice. Yes, indeed. And here's the final one. We nailed it, and it's even the same card value. Oh boy, there really is something to setting up a deck of cards in a certain arrangement, leaving it there for long periods of time, because I think you'll find that that deck is forever changed. Those cards will resist your efforts to mix them and arrange them in certain orders. Okay, boy, that's amazing. Okay, so that's the effect. So let me just give you some of what's going on here. I don't know if we'll tell you everything because you really do need to go to my channel to learn some of these shuffles and principles. Shuffles meaning when you have certain packet structures, you can convert those to different packet structures that have other qualities, that kind of thing. Okay, so there's quite a bit of that going on. But I do want to point out the kind of key parts here. So let me rebuild the deck for you, and I'll pause the video. Okay, I've rebuilt the deck, and so it's alternating in color. Now, for those who are up to speed on their card magic, you may guess that the Gilbreath principle is involved, and you would be correct, though I do need to point out that that's only a tiny portion of this entire effect, okay? And most of this effect uses principles, techniques, packet structures taught on my channel, okay? But let's get you started at least, because I teach the shuffles and the structure types and the structure preserving and converting mixing elsewhere on my channel. Okay, so you begin with an alternating packet as I have here. Okay, so when you go to do this, you could do a truncated version of my effect that really would still be a lot of fun for the spectator without having to do everything that I did, because there's quite a bit in here that's quite advanced. Okay, so if you wanted to start with an alternating deck, red, black, or even odd values, that kind of thing, you wouldn't necessarily have to show the spectator, or if you did, just show them very quickly and close it up. Okay. Now then I did, believe it or not, I did a Gilbreath shuffle, and this is something that I've never seen anyone do before, quite honestly, because I kind of puzzled through it myself before recording. So what I did was, first off, I noted the color of this card. Okay, so it is black. Okay, so what I did was I just broke off any number, it doesn't matter. Any number here, doesn't matter. I mean, leave enough cards to finish. Any number, and now this is the only important step here. When I break off this next part, I'll kind of show you, I need to stop at a red card. Okay, so there needs to be a red card right there. And then over here, it doesn't matter. Oh, I'm sorry. It doesn't matter anymore. You can just put down little packets. It doesn't matter where you stop in your cutting. Okay. The only important thing is this one here needed to be the opposite color of the original bottom card of the deck. Okay. If you do that and then do the steps I'm going to show you with the Rosette shuffle, this is a Gilbreath shuffle. Okay, even though it certainly does not look like one. Okay, and I'll leave it up to you to figure out, how is this a Gilbreath shuffle? But it is. Okay, so if you spin these, bring them together. Spin these, bring those together. Spin these, bring those together. Spin these, bring those together. And then you stack. It's easy to remember. We dealt out from left to right, these little packets, and then you stack from left to right. So if you do that, you're safe. This is technically a post-Gilbreath shuffled deck now, given the alternating structure of red-black at the beginning. Okay, so what that means in particular is it will have the property that pairs taken from the top will consist of one of each color all the way through the deck. Okay. So that's what's called the first Gilbreath principle. Okay, so that's a consequence of that principle there. Okay, and so in that sense, it doesn't really matter where I pull from, and that's why I was able to do, quote, 4 experiments, because in some sense, this deck is all the same relative to pairs of cards taken from the top will consist of one of each color. Okay, now what I did from there takes you into the world of my research into card magic. Okay, so we are now going to create eventually a 2-cycle relative to opposite card color. Okay, so let me just show you here. So, and I think you'll be able to follow this. Every pair taken from the top consists of one of the opposite color, right? So these two right here, opposite color. These two, opposite color. These two on the next level, opposite color. Same thing here, opposite color. And you just go through and do that. And that will be true all the way through. Oh, wait, I'm going too many. But we can go that many, I guess. Let's see. Well, maybe we will stop at 3 like we did. Okay, so let me just, I'm going to throw those away and throw those away. Sorry about that. Okay, getting excited about doing them. Okay, so we'll do it kind of like we did in the performance. I did 3 in each. Okay, so these 2 piles, move those out of the way. At each level, they consist of a red and a black in some order. These 2 at each level consist of a red and a black in some order. Okay, when you have 2 piles that have cards that are related at each level, we call them coupled piles. So these 2 piles are coupled in that sense. Same thing here. Well, when it comes to coupled piles, since these are coupled, if I set these on top, in fact, either order, technically now the larger piles are, quote, coupled. They'll have that property that as you go down one level at a time, each pair of cards at that level will consist of a red and a black, okay? And when you have coupled piles and you randomly stack those, it becomes what's called a 2-cycle. And this is a 2-cycle of cycle length 6. Okay, and in fact, I can even show you that so you can really see what's going on here. But all of this is taught on my channel. Okay, so 3. Okay, so here is the cycle length right there, 6. So what am I saying? The first card within each cycle, namely the 10 here and the ace here, are of opposite color. Move one over, you get a red king, a black 2, and then you get a red jack and a black 2. Then you get a red 5 and a black 3, and then you get a black 4 and a red 10, and then you get a black 8 and a red 2. Okay, so this is a 2-cycle relative with cycle length 6 relative to cards of the opposite color. Well, if you have a 2-cycle, you can randomly cut it. You can perform Charlier shuffles. You can do supercuts where I counted off a number of cards flipped and went into a Charlier. There's a bunch of things you can do when it's cyclic. It's essentially a cyclic packet. That's the larger classification in terms of names. But in particular, it's a 2-cycle having cycle length 6. Okay? Now, so you can mix this quite a bit, as I did in the performance, and then you can convert it to a mirrored structure. Okay, and that can be done by way of counting out half the cards, dropping the rest on top. That's called a 50% coating. You can Klondike shuffle this. It will become mirrored after that. And there are other ways to convert it from what it is now to a mirrored packet. Okay, now I only showed you a few within this video. Okay, but if you remember the very first showing that the cards were in pairs, I Charlier shuffled, and then all I did was I dealt out, you can rewind the video, I dealt out into 6 piles. Well, think about it. If this is a 2-cycle with cycle length 6, this is going to just put the corresponding cards within their respective cycle together. So namely, these will be of opposite color, these will be of opposite color, all of these will be of opposite color. Okay, so that is like the first little performance there. And then one important little fact too is, in fact, we'll go ahead and just kind of do this really fast here. I wanted to bring the stay stack principle in. Okay, so here we go. Randomly stack those. This is a 2-cycle now. So if you were to convert it to a mirrored structure, 50% coating will do it, it's mirrored now. Okay. Now once it's mirrored, you have the stay stack principle, which allows you to just mix the cards in so many different ways without harming anything. Well, how do we know that it's mirrored? Well, just look here. The outer ones, opposite color, opposite color, opposite color, opposite color, opposite color. The ones in the center are opposite color. That's called a mirrored packet. Well, mirrored packets have an amazing property where for each divisor of the packet size, you can deal the cards into that many piles, randomly stacking from left to right or right to left, and it doesn't change the fact that it's mirrored, as you can check here. Okay, so you can deal out because there's 12, you can deal out into 3 piles or 4 piles or even 6 piles with random stacking from left to right, right to left. And I also have this additional stacking that some of you may have seen. It's called leapfrog stacking. So it's an apparently more random looking stacking that also works. Okay, now once it's mirrored, of course, well, think about it. What does the Klondike shuffle do? It takes the top and bottom off as 1. So all it's doing is, for the cards in that mirrored configuration, it's just bringing the corresponding cards together, the ones that are mirrored images of each other, okay, in the mirrored positions. Well, that's going to confirm our hypothesis that, boy, these cards just can't be mixed. They just want to separate into a red and black and so forth, okay? And then I also did a supercut. I don't know if we'll show all of this here, but I did a serpentine deal, which I talk about. I did a ferrule shuffle. Ferrule shuffles preserve mirrored structures, but they convert 2 cycles to something called AMP structures, adjacent mirrored pairs. So really there's 3 primary structures that I look at. And you can't see it, so I'm going to angle it here. So we have 2 cycle here, M for mirrored, AMP. That's where cards taken from the top are related by whatever categorical relation you've set up. And so really everything that we were doing, we were bouncing around between these 4. Those are coupled piles. That's CP for coupled piles. So we were just kind of staying within this realm right here. Okay. And that's after the Gilbreath shuffle. And so the amazing thing is, most people think that once you've performed a Gilbreath shuffle, all magic is over. Once you've shown that cards are, let's say pairs of cards are in opposite color, that kind of thing, there's nothing more you can do with these. That's just the beginning of the magic, if you know what you're doing. You can now randomly stack these and then just move on from there into just tremendous routines that take advantage of the fact that you have them in these opposite color pairs. Okay, so instead of being a dead end, like this is the finale for a routine and there's nothing more we can do with these cards because look at them, they're just a mess. No, this is just the beginning. You know, you just randomly stack these. This is an AMP now, okay? And then you can go from here to turn it into coupled piles, as I mentioned. Now it's a 2 cycle. Once it's a 2 cycle, you can change it to a mirror packet by way of the Klondike and so forth. So you're drinking out of a fire hydrant here. And I can even show you it's mirrored now, right? The cards on the opposite ends, as you come in to the center, will be of opposite color. So black, red, red, black, red, all the way to the center. So anyway, so this is meant to be kind of an encouragement to take a look at some of the principles and techniques and packet structures taught on the Absolute Math Magic channel, because once you have some of the basics down, you can mix and match these structures and shuffles in ways that will enable you to create original routines that no one has ever seen before, that will utterly blow away your spectator. They'll have no idea how in the world you were able to accomplish what you did, given all of the random choices you allowed them to make along the way. So anyway, so I hope you enjoyed that. Hopefully that wasn't too long. Very few of you will make it to the end, I'm sure. But thank you for watching, and once again, take a look at other videos on the Absolute Math Magic channel.